The purpose of this experiment was to model motion in nature that we found interesting using the concepts and principles that we've learned throughout the semester. I chose to model a collision between a basketball and a lacrosse ball, much like the tennis ball and basketball example that we saw in class with Dr. Schatz. Although I was unable to correctly model the entire motion of the system, I do know the height that the lacrosse ball should have reached, and I was able to calculate that correctly. In this video, you can see the motion that I decided to model. I chose to model both the motion of the basketball and the motion of the lacrosse ball in my computational model. The falling motion of the basketball and the lacrosse ball could be modeled using a similar method that we used from Lab 2 when we were modeling the falling motion of an object that weighed less than a rock. So, following these steps, we were able to accurately predict the position of the lacrosse ball and the basketball, assuming that they both started from rest and that the only forces acting on them were the force of the weight force and the drag force. Although we have not learned how to model a collision during this semester, we do know how to model the motion just before and just after the collision. All we need to know is the initial velocity of both of the objects just after the collision. In frame 1, you can see that as the two objects fall, they follow the same velocity. In frame 2, you can see that as the larger ball hits the ground first, the magnitude of its velocity is the same, however the direction has reversed so that it is now traveling upward. Frame 3 is modeling that since the basketball is traveling upwards at a velocity v0 and the lacrosse ball is traveling downwards at a velocity v0, it would feel to the basketball as if the lacrosse ball were hitting it at a velocity 2 times v0. In frame 4, you can see the final velocities of both of the balls. The basketball is traveling at a velocity VO, which is equal to the initial velocity that it had when it first hit the ground. The lacrosse ball is traveling at a velocity 3 times VO because when it hit the basketball, it was traveling at a velocity 2 times VO, so its magnitude stays the same, and it also absorbed the velocity of the basketball. Therefore, 2 times VO plus VO equals 3 VO. In this model, the falling motion is predicted accurately. However, when the balls are set to launch back up into the air, they keep going rather than stopping at the appropriate height. However, calculations were made to predict the appropriate height. Based on the principles of the conservation of energy, we know that the kinetic energy of the lacrosse ball before the collision has to be equal to the change in potential energy that occurred after the collision. Setting these two quantities equal to each other, we are able to determine the height the lacrosse ball should have traveled to before falling back to Earth, which is 2.92 meters. This value is consistent with the experimental data that was recorded with Tracker.